Hi everyone and welcome. I'm Hilik Paz from Marto AI. Marto is a platform for managing your Gen AI assets. This includes your prompts, model configurations, datasets, and evals. From the minute you write your initial prompt, testing and experimenting with it to make sure it performs as you expect, to the time it's running in production with detailed observability and metrics. In this session, we will take a look at the key role Evals play in bringing your Gen AI app to production. We will see the process of designing, evaluating, and refining prompts for an LLM-based application. So let's start. So what are evals? Evals are a systematic method we use to measure the performance, capabilities, and basically the replies that we get from AI models. They are key in determining how well a prompt or a model output meets the specific objectives that we have. The key features for evals are being measurable, being able to quantify various aspects like accuracy, relevancy, structure, repeatability, meaning consistent assessment across different iterations, and being actionable, provide the insights we need to refine the prompts and to improve the outcome. So what have changed? Software testing had been around for decades. Why are we talking about a new method of testing? The first thing is the boundary. We move from a very well-defined and structured output and error format in traditional APIs to complex and unpredictable formats, errors, and mistakes. We're moving toward a non-deterministic world where even similar and sometimes identical input receives or might receive different outputs. So we're moving from a very clear pass or fail criteria to a world where we would measure different aspects of the replies that we get, and we will compute some kind of a scoring that will tell us if we're hitting the target or not. Evals transform prompt engineering from guesswork into a scientific process. By making interactions measurable and repeatable, they will ensure LLM output aligns with our business objectives, enable data-driven decision-making and prompt refinement, and reduce the risk of unforeseen issues in production. So let's take a look at an example use case. This is our demo application. Imagine that you were given a task of developing a technical support bot for a company called AppMaster. The AppMaster support bot is designed to help technical users find answers efficiently. It pulls information from various sources and a knowledge base, and it aims to provide an accurate, concise response. Our challenge is to craft a prompt that will ensure the bot delivers high-quality answers. So let's take a look at our initial prompt and the AppMaster support bot. Here's the first version of our AppMaster support bot. Let's try to ask something. We got a very simplistic reply and not something that would really help our users. So let's see how we can improve. So we got our bot up and running, but how do we measure success? We'll need to define criteria for each business requirement we got. For example, response relevancy, its ability to build on the knowledge we pass in the context, etc. We'll use different eval methods for each criteria. We'll see some examples in a minute. And we will build test data which we can use to iterate and have a complete test case. We've seen that good evals are aligned with the business goals that we have. In our specific example, the AppMaster support bot evals could measure accuracy, politeness, response times, and the expected output format that our code expects to get. So let's first analyze the different types of evals we can use. In the first category is the content-based evals. In our example, we have a dataset with samples for expected input and expected output. We can compare the actual responses that we will get in our experiment with the expected one. Such a comparison will use vector similarities, which is a mechanism for determining the contextual distance between two text blocks. Other content-based evals might be checking for existence of certain words, maybe checking for the absence of sensitive data, etc. The second category is the format. It's very often a requirement to return a response in a very specific format. It can be that our code depends on such a structure or fits the user expectation. Either way, we will need to look at the format and validate it against our requirements. In our example, the code expects a certain JSON schema. We will see in a minute how to verify it. Third category is various qualities, like making sure that the bot is using the documents that we are passing as part of the context and is grounding the answers based on these documents. And of course, other guardrails or non-functional aspects like politeness in our use case, which is one of the requirements we got for building the bot. We can use different mechanisms for running our evals. This can be deterministic or rule-based evals for checking text matching, for example, or regular expressions, or model-based evals that can use LLM as a judge or other models for other capabilities like vector similarity. In our example, we will combine both mechanisms. Where possible, we will be using a rule-based one, and where required, we will use a model-based one. The pros and cons are quite obvious. The deterministic ones will be very fast, very cheap to use, but sometimes limited and rigid, while the LLM-based ones will be very flexible. We can basically ask any question we would like. They will be relatively easy to use, but they can be expensive and they themselves are non-deterministic, so we need to be very careful of how we measure or how we look at the answers that they reply. So let's see a few examples we will use to optimize our app support bot. The first one, vector similarity. As part of the requirement for our support bot, we got an example of how an expected output should look like. This includes both the structure and the content we expect to get for a specific set of inputs or a user question. When we run the actual experiment, we get a reply back from the LLM. We can read all this text and try to evaluate ourselves if they are similar or not, but in our case, we will use vector similarity that will save us the trouble of going through all those details. The response that we got back is very similar from a contextual point of view. The second eval will be a response format eval. Here we can use a very simple deterministic based eval for checking, for instance, certain regular expression that will match the expected JSON schema that our code requires. And lastly, we will use some LLM-based evals. In this example, we want to verify that the bot answers in a polite manner and mention that it is the friendly app master support bot, so we will use another model to verify this. So how do we put those evals into action? We've defined our evals criteria. What's next? We will now experiment with our prompt. We will first make a template out of our prompt, putting variables or placeholders in the places we want to inject dynamic data. We will prepare test data, which will be our data set, and we will iterate over it with the eval metrics that we've just defined. We mentioned the need to prepare test data. What makes a good dataset for such an experiment? The data should represent real-world scenarios, meaning the inputs that we expect users will enter in our AppMaster support bot app. But we should also make sure to include data that represents edge cases and unexpected inputs that users might enter into our app. So let's see a live experiment of everything that we've just defined. So this is our app support bot notebook. It includes the prompt and the instructions that we give the LLM, the dataset that we will use for our experiment, and we already have a couple of evals that we've defined. The first one is using custom LLM for validating that the bot is answering in a polite manner. The second one is a simple deterministic one, making sure that we greet the user. Let's add a couple of others. We'll pick the relevancy eval for making sure that the results are grounded with the documents that we've passed. And we can even validate the JSON schema that we require in a deterministic manner using a regular expression. We will run the experiment and see the results that we get. So as we can see, we get a relatively poor results on several of our evals, including the JSON schema. and we can see the individual failures on specific inputs. So let's go ahead and improve the prompt and the instructions we gave to our bot. We'll include a more detailed example for the response format, as well as strengthening other instructions, and we'll run it again. We can also pick another model and see if that will have any effect on the results that we get. So we'll pick Claude and we'll run it again. And let's take a look at the responses that we got and the Evals results. So as you can see, we got a much better results this time, and all of our Evals have passed with 100% success rate. This is true for both models that we've tried, so the improvement we did to our instructions made a difference. Let's compare all three experiments that we've run. And as you can see, we improved the instructions we gave. We still get very high similarity score comparing to the expected results that we gave as part of the dataset. But this time we have a much higher success rate, actually 100% success rate in our Evals. So let's push our new prompt into production and see how the new bot behaves. We'll ask the same question. And this time we get a much more detailed answer with various options that would assist the user in solving his problem. So to sum up, we've seen how we can use Evals to iterate and improve until we reach a prompt that satisfies our business requirements. Thank you very much for your time today. I hope this session had been insightful. If you have any questions, comments, or would just like to keep in touch, please follow us on LinkedIn or visit our website, and you're welcome to try us out at arato.ai.